sure you've all seen or heard the song from Frozen, Let It Go, Let It Go. I'll spare you my terrible singing, but sometimes SAT math could be like that. Now, Elsa was singing about like being herself, let it go. In math, what you gotta do sometimes is let a problem go. So this is October 2020 SAT, and we're looking at section 4, number 29. And this may be a question that you look at and you're like, yeah, I don't know how to do that, which is fine, let it go. If you're scoring, 750 plus, then this is a question you want to do. But if not, then it's time to sing like Elsa. My name is Paul Pasulka, IB Masters Learning Center, and IBMasters.com. And yes, today we're looking at October 2020 SAT section 4, number 29, which reads, in the figure above, circle has center O. What is the area of the shaded region? Okay, so what do you got to do first? What we're going to do first is we're going to find the area of the sector. So how do I get the area of that sector? It is going to be, the sector is going to be 1/6 of the area of the circle. How do I know that? The 60-degree angles tells me so. So 60 degrees out of 360, 60 over 360, that will reduce to 1/6. So what I'm going to do is I'm going to take 1/6 of the area of the circle. So it's going to be 1/6. And remember, area of the circle is pi r squared. So 1/6 pi times 4 squared. And so it's going to be 1/6 times 16 pi. And it's going to be 16 pi over 6, which reduces to 8 pi over 3. Okay. And so just looking at that, now we don't have our answer yet. So it's just not straight 8 pi over 3. It looks like this is going to give you a 4 pi over 3. So we're thinking at this point that it's C or D. If that's all you do, you mark your answer and you move on. But what we're also going to do is we're going to get the area of the triangle. How am I going to get the area of the triangle? The area of the triangle, it is a 60-degree triangle, and all radii are equal, so those two sides must be equal. If those two sides are equal, the opposite angles must be equal. So it's a 60, 60, 60-degree triangle, equilateral triangle. And so one good thing about equilateral triangles is if you draw the altitude to them, you've got a 30, 60, 90 triangle. And there you can see the base is 4. And if you know your relationship with a 30, 60, 90 triangle, then you know that the height is 2 root 3. 2 root 3. Even if you don't know that, splitting it down the middle is going to give you a 2 here. Equilateral triangle, all sides are equal, so you know that length of AB is 4. And then you could do Pythagorean theorem. 2 squared is 4, 4 squared is 16, and then it's 2 squared plus b squared equals 4 squared. And you get 4 equals b squared plus 16. You subtract your 4 from both sides, you get b squared equals 12. Take square root of both sides, and you wind up square root of 12, which is also square root of 4 times square root of 3, which is also 2 root 3. So anyway, that altitude is 2 root 3. And remember, the formula for area of a triangle is, and what am I doing here? I'm taking the area of the sector and I'm subtracting the area of the triangle, minus 1/2 base times height. So 1/2 the base is 1/2 of 4 times the height is 2 root 3. Okay, and then we get 8 pi over 3 minus, and this cancels. I wind up getting 2 times 2 root 3 minus 4 root 3. And when you look at the answer choices, you might see that nothing perfectly matches, but a quick distribute in answer choice C would give you 8 pi over 3 minus 8 root 3 over 3. But answer choice D is 8 pi over 3 minus 4 root 3. So that's going to be your correct answer. If I pulled out a 1/3 here, then it would give me the same result, but it's a little wonkier to look at it that way. Thank you for joining us today. If you like this video, click like. You could share it with someone who has difficulty with this crazy hard geometry type of question. If there's any question you'd like to answer from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. And click subscribe so you don't miss anything. Have a great day.